Okay, so it just looks like slightly different graphics from the addressing information that was on Cengage for this one. And some of it might, it might hit differently. It might make a little bit more sense. So this is talking about IPv4 32-bit, and then it talks about just basically how they're made up. If you have any questions while I'm zooming through this, let me know. And this is just explaining subnet mask and IPv4, which we went through in the other class. This is just a very long explanation with prefix length and subnet masks that will show you basically the same stuff that we went over in the other one, just in a slightly different format. Okay, logical and Boolean operation. I do not enjoy doing this one, but if you have to, this is just an explanation of logical and Boolean operation when used to determine a network address. So logic AND is the comparison of 2 bits where only a 1 and 1 produces a 1, and any other combination results in a 0. So that's binary. So 1 and 0 are basically the only options. So 1 is true and 0 equals false. It's just down to the super basics as far as like computer language and stuff goes. And that one, when I went in there, the link to the videos on their stuff doesn't work. So I was like, oh, okay, yeah. This one is the network host and broadcast addresses, what we went over previously, and it just breaks it down into ones and zeros in there if you want to see how that's broken down. This is out under the document section under Cisco PowerPoints, so you guys can cruise through these if you want to, or save the slides. So unicast transmission, this is sending a packet in one direction. Just remember, uni means one direction, one destination IP address, and this is just a graphical representation. This goes here and goes only in this one direction. Broadcast is sending a packet to all other destination IP addresses. I kind of like to think of it as like a shotgun effect, everything just all at once. Multicast is sending a packet to multicast address group. This one sends a packet to a multicast packet to multicast group address. So we went over pretty much extensively. Oh, someone. Yeah, don't from Idaho, so I figure most people know gun speak when you're talking about technology. For some reason, it usually links over in some way. Okay. So here's our public and private, which we talked about, and that's the network address and prefix. And then there was that one, remember we were talking about the private addressing range, and there's some more information on that. Routing, that we talked about the NAT and PAT. This is talking about NAT with IPv4. This is using loopback addresses. This is it's used when you, it's basically just when you're running something in a loop so that you can test to make sure everything is functioning okay. Link local addresses, legacy classful addressing. This, they briefly mentioned this, the 5 different classes. This is one of those things that historically it's nice to know, but it's also one of those Google is your friend, so you'll remember that it's out there. IP address assignment. So the Internet Assigned Numbers Authority, or IANA, that manages and allocates the blocks of IPv4 and IPv6 addresses to 5 regional internet registries. And as you can see, they're just color coded out. And then they are responsible for allocating IP addresses to IPs to provide IPv4 address blocks to smaller ISPs and organizations. Sorry, I have a very grumpy tortoiseshell who sometimes likes to give her opinion about the world. So if you heard her monologue there, that was just her telling me she didn't like where my computer was sitting. Then we went over network segmentation in the other one too. This is basically all the same stuff. Large broadcast domains. This one talks about the problem with large broadcast domains. The host can generate excessive broadcasts and it negatively affects the network. So what you do for that type of situation is to reduce the size of the network and create smaller broadcast domains. And that's where you get subnetting. Dividing the network addresses into 2 subnets, 200 users each, and then it shows the subnets there. Broadcasts are only propagated within smaller broadcast domains. And that's just basically so that the traffic's a little bit more manageable. This is another section for reasons for segmenting networks. Location, which I've seen done a ton, especially if you have multiple buildings or multiple floors, or even if you have multiple departments in a large building. Group or function, sometimes if you have multiple locations and then you have multiple groups. A lot of things I see done with like universities, you'll see faculty, staff, and students are the 3 big groups. So you have your faculty, and then you have non-faculty staff members, and then you have students that are actively enrolled. Those are the big 3 for group and functions for those sorts of things too. And
another
then
one is segmenting networks, especially in like office buildings and high rises, where you have quite a few separate businesses occupying the same building.
Yep, that's another. Yeah, there's a bunch of that happens, like especially if you have like either a big high rise, or you have even in rural areas like this where you have like those little shopping mall type areas. You get that down there, that type of area too. So that's a good point. And then device type is always a good reason for that too. Okay, so we went over this and it was talking about octet boundaries, and this is just another way that they that they put it out there with the 1s and 0s, and I think it's just nice to go through this so that you can see the difference between how Cisco words it and how Cengage does. And this is subnet on octet boundaries. And this is just looking at them and reading them, getting familiar with those is a good idea. And there are 6 ways to subnet a 24 network. And this talks about the different subnets and numbers of hosts and on that. And like I said, the videos on here do not link correctly. We will have some packet tracer exercises, but I didn't want to use their online ones. I wanted to be able to, you can download packet tracer, and some of the other teachers had some source files that we could use just to play around with. I think everyone's computers should be able to support that, but we'll give it a try and make sure that we can all get to use it. Okay. All right, subnets with a slash to prefix. This is just an example of that, or many examples of that. 100 subnets with slash to prefix.
You have a question in chat.
Oh, don't ask me to brain big. So a subnet is, if you think of it, it's just a subnetting is when you take just a chunk of your network. That's all it is. It's just a divide of your network. So at its very basic concept. So they have to have certain ranges, because physically there are only so many IP addresses and network addresses in IPv4, IPv6. And then you'll see these different formulas like this. And that tells you, am I taking the whole network, and am I doing it in this many subnets? And it can get a little complicated. This is just kind of showing you these different ways that you can take these subnetted out portions of the network. So that's basically at its root what it is just a divided portion of the network. And these are just all the different things that you can. I absolutely dislike the subnetting and calculating stuff. So if there's anybody that's really good at it, let me know. But I'm going to go grab just a couple of YouTube videos, and then I'll throw them into the documents section along with the ones I showed you guys yesterday, because I am terrible at explaining this. Math in general tends to buffalo me. And then unless I'm just doing it for the sake of doing it or using practical examples, I have a difficult time explaining it sometimes. Okay, so private versus public address spaces. So enterprise networks will have the intranet. That's your internal network, typically using your private addresses. DMZ, company internet-facing servers, device in the DMZ use public. So DMZ is a demilitarized zone. A company could use the 10 to 8 and subnet, or the 16 or 24 network boundaries. The DMZ devices would have to be configured with public IP addresses. So mostly it's just knowing how you're going to subnet out in order to divide and subdivide up the chunks of the IP address ranges. So this is minimize unused host addresses. And the reason you want to do this is that way you just don't have a whole bunch of different ones sitting out there being unused, and you have an easier time keeping track of what's out there and what isn't. And this is just an example of efficient IPv4 subnetting. So in this one, they have corporate headquarters, 5 sites, and 5 internet connections. And then, so they have 10 subnets, and then they just want you to run through and see what they've done on this. More videos. Okay, address conservation is what they were talking about a little bit there. Okay, so basically when they're doing address conservation, they want to do allocation of their subdivision of the network so that they lose the least amount between sites. So what they do, the easiest way to think of it is, depending on what you're doing, you have your set number, and then you just need to, okay, I need to take out a little chunk over here and maybe a big chunk over here so that I have more that eventually we can reassign on the end. And if I take a big chunk here and a big chunk here, it's harder to you can't really reassign them as you go with that particular setup. And this is just more explanation of how they applied the topology. And VLSM is just another one of the different options that you can use. It's just one of those subnet type things. Okay, network address planning. Network address planning is crucial for development of scalable solutions, especially on enterprise networks. The reason you want to do this is if you poorly scale the beginning of your network, adding additional network appliances and things like that in the future is going to be much more difficult, because a lot of times when you're looking at early projects, you can see the issues where people poorly scaled and then had to like basically start from scratch to redo everything. And you want to avoid doing that, and you want to avoid as much time and resource usage. So this is just to put it all out on paperwork and spend a lot of time there rather than when you're having to do the actual physical resources. Make sure you remember our kind of like the power supply thing where we were talking about map up everything that you need to use and then plus 30. It's kind of similar in how they do this for a network to map up, okay, this is how much we currently have and this is our expected growth trend. And it kind of gives them an idea of how to do their address planning. So there are different types of devices that require addresses. There are end user clients, servers and peripherals, servers that are accessible from the internet, intermediary devices, and gateways. So most of your end user clients will use the dynamic IP addressing to reduce errors and burden, and because it is also better for your support staff, because if you use DHCP, then you have less people going out there to physically touch the device or remote into the device and set everything up. They just have a little radial they click and it goes. Servers and peripherals, they should have predictable static IP addresses. Usually when they do the subnetting, they have entire sections that are just blocked out for your servers. Servers that are accessing your internet servers, they have to have a public address. And a lot of the times now they're using that NAT that we talked about. Are there any questions on NAT? That one I actually originally had to kind of have explained to me from our network engineer just to understand it a little better. So does everyone understand the network using NAT on the public and private IP addresses? Okay, I'm going to assume that means yes. And then devices are assigned addresses for network management, monitoring, and security. The intermediary devices, those could be all sorts of different items. Kind of you understand it, or kind of you have a question? You kind of understand. Yeah, I think for some reason with these, it's just all about presentation because different learning styles address different things on this. So I'm going to go out and find a couple of YouTube videos. But for me, the simplest way that I remembered it was you have your public internet. And in order to save all of these IP addresses out here from being used up from everything. Yeah, security cams versus Samsung fridge. Yep. So when you're doing your public addressing, they were running out rapidly. So they decided to do network address translation so that you would have your private networks, and they have their own setup, their own network IPs, and then you use, I think of it like kind of like a funnel. Those all funnel in to your access out to the internet, and then they usually have just a couple of static IP addresses that they funneled back and forth through the traffic for your public and private. So that way it conserves how many public IP addresses are being eaten up, and that way it also allows you to have management of your internal assets. Does that make a little more sense? Okay. Yeah, I had to think, I had to actually draw it out because I'm very visual when it comes to certain things. And once I drew it out like that, I was like, oh, okay, that makes a little bit more sense. And then lastly, routers and firewall devices. Those are the gateways for hosts in the network. And I don't think we need to worry about this. Okay, that's just the end of it. Okay, so are there any questions? I know it was just a kind of a recover of stuff that we've already done, but were there any questions about anything that we talked over the last 2 days? If I don't understand it, I've got a couple of people that I know that are really good at it, and I can see if I can get a better explanation for some of the questions if you have something that you specifically want addressed. So questions about network addressing, or we did cabling this earlier this week. Questions about anything else so far? Nope. Is everybody doing okay? Yeah, there's a lot, you know, for some reason I have done like the text is really dry, but I did better when I was physically seeing diagrams and having someone explain them. Sometimes if you go out to like, there's that Professor Messer Network Plus, he does a fantastic job. His stuff is approachable. And I know that he has a Network Plus because he has like a bunch of CompTIA stuff, that there's a Network Plus one. And I highly suggest if you're having problems, these concepts, go look at the first, I think they're like the first maybe 6 sections that we're doing for this class. And then the last part of it's going to be for the next class. So I would really suggest looking at his videos. There are a bunch of great network analysts that have posted on YouTube, lots of really great stuff. And if you find one that you're like, whoa, hey, this really made me see things differently, post it on Discord or shoot it to me in an email and I'll post it. Oh, it's Professor Messer. Hold on. There we go. He is fantastic. And if you just type Professor Messer just like that in YouTube, you'll find his channel. So yeah, I used his stuff for certification exams myself. When I took the Certified Ethical Hacker, I did not like some of the material that I had, so I had to reach out and do a bunch more research on my own. And I hit his stuff and was like, wow, this is fantastic. So I highly recommend that. So, okay, tomorrow we are going to do our second ethics lecture / participation. I think we did pretty well last time. We had a good mix of people talking and texting. So we'll do that tomorrow. And tonight I'm just going to be on here if you need help, but I will warn you, I'm pretty scrambled right now. So I've been up and down because I've had really bad muscle spasms. So if you guys need anything, Discord, hop on Zoom, email, let me know if you're having any problems with Cisco or with any of the other stuff. Okay. Other than that, I don't think I told you guys I'm reformatting the YouTube channel because I have everything on unlisted. If you go look in the resources section, you can scroll back and see like the old video links and stuff, but you can only get there via link. So I'm have to jump some hoops with YouTube in order to get the upload and processing speeds and things like that for the videos, as otherwise they only give you 15-minute clips. So I'm working on that to get these all up. So I'm still saving everything and processing it. I just wanted to let you know what was going on. Anyway, otherwise, if you don't have any questions, you guys have a great night, and I will see you tomorrow.